Hey everyone, welcome back to another video here on TryHackMe. I am John, and today we're going to be taking a look at Linux Fundamentals Part 1. Embark on the journey of learning the fundamentals of Linux, learn to run some of the first essential commands on an interactive terminal. Now, if you have had very little experience with Linux, or maybe none at all, you're in the right place. Maybe the command line is kind of a spooky thing that, maybe you're not very comfortable with it. Or maybe you've had some practice and you want to polish things up and get additional practice to really solidify those Linux skills. If so, you are in the right place. Today we're going to be going through the first part of the Linux Fundamentals series, and I recommend going through all three of them. And these are really going to help solidify your Linux skills into making you a professional. That being said, let's go ahead and dive right into Task 1, Introduction. Welcome to the first part of Linux Fundamentals Room Series. You're most likely using a Windows or a Mac machine. Both are different in visual design and how they operate. Just like Windows, iOS, and Mac OS, Linux is just another operating system and one of the most popular in the world, powering smart cars, Android devices, supercomputers, home appliances, enterprise servers, and more. Linux is kind of everywhere, and yes, a bunch of things such as Android are just Linux under the hood. A lot of game consoles are actually just Linux under the hood because Linux can be trimmed down pretty heavily and customized very, very heavily as well. We'll briefly touch on that throughout the room just to give you some background knowledge. That being said, let's go ahead and continue. We'll be covering some of the history behind Linux and then eventually starting your journey of being a Linux wizard. This room will have you running your very first commands in an interactive Linux machine in your browser, teaching you some essential commands used to interact with the file system, and it will introduce you to how users and groups work on Linux and what that means for us as penetration testers or just security professionals in general. Let's go ahead and mark this as completed and move into Task 2, a bit of background on Linux. Where is Linux used? It's fair to say that Linux is a lot more intimidating to approach than operating systems such as Windows. Both variants have their own advantages and disadvantages. For example, Linux is much more lightweight, and you'd be surprised to know that there's a good chance you've used Linux in some form or another every day. Linux powers things such as websites you visit. Most websites are hosted on Linux servers with Apache or another server that's running them. Car entertainment, control panels, a lot of those will run stripped-down versions of Android or Linux as an embedded system. Point-of-sale systems such as checkout tills and registers in shops. Very common for those to be Linux. Critical infrastructures such as traffic light controllers or industrial sensors. A lot of times those will be very heavily trimmed down versions of Linux such as Alpine or something even thinner. That's definitely something that I recommend looking into, just traffic controllers and things like that. It's very interesting because those are controlled by just basic operating systems like Linux. Let's talk about the flavors of Linux. The name Linux is actually an umbrella term for multiple OSs that are based on the Unix, another operating system. Unix is the, overarching flavor for how the operating system is designed, and Linux is multiple flavors of operating systems that fit under that. When we say flavors, there are many different styles of Linux with little different tweaks, ways that they function, different package managers. Don't worry about knowing this right now, just have a general background knowledge that there's a bunch of different kinds of Linux. Thanks to Unix being open source, variants of Linux come in all shapes and sizes, suited best for what the system is being used for. For example, Ubuntu and Debian are some of the more commonplace distributions of Linux because they're really extensible. So for example, you can run Ubuntu as a server, such as for websites or web applications, or as a fully fledged desktop. You can install a GUI on that. Even if you're starting with a server installation of the operating system, you can install the actual user interface and give yourself that GUI. For this series, we're going to be using Ubuntu, which is really common. If you've ever run maybe a Minecraft server or something like that, you've probably used Ubuntu in that specific case. Ubuntu server can run on systems with only half a gig of RAM. Not a lot of RAM there. Similar to how you have different versions of Windows 7, 8, and 10, for example, there are many different versions and distributions of Linux. So the next part is a little bit of research. What year was the first release of a Linux operating system? I'm going to pause here for just a moment. If you want to look this up yourself, feel free to search for it now. Otherwise, I'm going to go ahead and give you the answer. The answer to this is 1991. That is when the first release of Linux took place. Let's move on to task 3, interacting with your first Linux machine in browser. This room has an Ubuntu Linux machine that you can interact with all within your browser whilst following along with this room's material. However, to get started, simply press the green Start Machine button just right over here on the top right of this task, indicated by the arrow to the right. Let's go ahead and press that now, and we'll let this start loading. And you can see that we have this card with active machine information. So the first one over here is the title. That's just useful to know what's running. Don't worry too much about this. It's not very important. Then we have the IP address. This is how we're going to interact with the machine for the most part. This is how we know what machine we're going to. Think of it, if you're not familiar with with IP addresses, think of this as like the street address that we've given the machine. And then we have the expiration timer. All these machines spawn with a default of 2 hours for their time. However, we can extend that if it falls under an hour, and we can also terminate it early if we're done with the machine. All right, let's move in over here. So we can see that this is a basic overview of what I just covered, and at some point we will have this pop up with the terminal. Let's go ahead and mark this as completed, and we will move into task 4 while this is still loading. As we previously discussed, a large selling point of using operating systems such as Ubuntu is how lightweight they can be. This, of course, doesn't come without its disadvantages, where, for example, often there is no GUI, so graphical user interface, or what is known as a desktop environment, that we can use to interact with the machine unless it has been installed. So again, if you have something that's just a command line, which we're going to see over here, you can install a desktop if you really wanted to. That being said, a lot of time system administrators will opt to just use the command line just because it's as powerful as using the desktop, and for most things it's a lot faster. A large part of interacting with these systems is using the terminal, which we're going to see here in just a moment. The terminal is purely text-based and is intimidating at first. However, if we break down some of the commands, after some time you will quickly become familiar with interacting with the device. And you can see an example of the terminal here, and I'll demo it here in just a moment. We need to be able to do basic functions like navigate to files, output their contents, and make files. The commands to do so are self-explanatory once you know what they are, of course. That being said, real quick meta note on that. As far as these commands go, I do recommend taking notes on these commands. It'll make it easier to pick them up with practice as well. Additionally, I recommend learning what these commands are short for. A lot of them are abbreviations. So for example, who am I? If you read that out, pretty self-explanatory. We're trying to figure out what user we're logged in as, and so on and so forth. As I go throughout these rooms, all 3 of them in this series, I will read out how I remember them or what they stand for, and so on and so forth. That being said, we're going to cover these 2 commands in this task. So the first one here is echo. So echo is as it sounds. We're saying something, or we're asking for something, and we want the terminal to repeat it back to us. It's like saying something into a cave, you hear it come back. And we can see in this case that if we type echo and then hello world, it's repeated back to us. Pretty straightforward. This within the grand scheme of things, is very useful for debugging, especially if we are going to do scripting. You don't have to worry about that right now. That's just to give you an idea of what we would actually use this for. This is also very useful for sending things between different commands, as we can chain things together, but don't worry about that. That's something that comes with practice. The next one that we have, and I alluded to this briefly before, is who am I? Now, if we type who am I, this is going to tell us the user we're logged into. Pretty cool. Let's dive into the questions. If we wanted to output the text, TryHackMe, what would our command be? That would be echo and then TryHackMe. Note, if we don't have spaces here in the actual text that we want to have echoed out, we don't have to use quotes. I had to use quotes here because I have a space. What is the username of who you're logged in as on your deployed Linux machine? That is TryHackMe. And note, I'm pressing enter at the end of typing these in. You can do that to submit the answer to the question, and that way you don't have to click correct answer, or click submit rather. Let's go ahead and move into task 5, interacting with the file system. So far, we've only covered the echo and whoami commands. Not all that useful when you consider the things that we need to do, including navigating the file system, read and write to it as well. In this task, we're going to be learning the commands so that we can do just that. Just like the previous task, I'll display the commands in the table in the heading down here and some show examples of these commands being used. I'm going to go ahead and go past this. I do recommend taking notes on that. However, I'm going to go through and break down the commands one by one. Listing files in our current directory with ls. Before we can do anything such as finding out the contents of any files or folders, we need to know what exists in the first place. This can be done using the ls command, short for listing. And we can see a nice demo of it down here, where you can see that the Ubuntu user in this case has run ls, and we can see that it looks like we have a couple directories here. In the screenshot above, we can see there are the following directories and folders, and I won't go through that. You can see them right up there. Great, you can probably take a guess as what to expect a folder to contain given by its name. And that's very common. This is the same as what you would see in a Windows computer, where if you're in your user's home directory, in Windows or in OS X, you can see that you have like a pictures folder, a music folder, and so on and so forth. Pro tip, you can list the contents of a directory without having to navigate to it by using ls and the name of the directory. So for example, if I do ls, we can see that we have a whole bunch of different things, and I do ls folder 1, and I want to trim off that end. There we go. We can see that there's nothing in it, so bit of a bad example, but you can see that we could list what was in it, if anything. Changing our current directory with cd. Now that we know what folders exist, we need to use the cd command, short for change directory, to change to that directory. Say if I wanted to open the pictures directory, I'd do the cd pictures, where again, we want to find out the contents of the picture directory, and to do so, we would use ls once we've actually moved in there. Let's demo that real quick. So let's see, we will cd to folder 2, and then ls, and we can see that there's nothing in folder 2, but we can go back up a directory by doing ... That means return to the previous directory. And there we go. And we can see in this example, we have moved into this directory and there are a bunch of pictures of dogs. Outputting the contents of a file with cat. And let me go ahead. I'm going to clear my terminal on the right-hand side. This is done with Control and L. So I'm holding down Control and then hitting L, and that clears the screen. Pretty nice. Whilst knowing about the existence of files is great, it's not all that useful unless we're able to view the contents of them. We will come back to discuss some of the tools available to us that allows us to transfer files from one machine to another in a later room, but for now, we're going to talk about simply seeing the contents of text files using a command called cat. Cat is short for concatenating and is a fantastic way to output the contents of files, not just text files. Actually, cat will, even if you have binary files, so think like executables on Windows or things that you would run, it will do its best effort to display everything in that file. You'll get a lot of random, just garbage text, but you can definitely see what's in the file. So just something to be aware of. In the screenshot below, you can see how I have combined the use of ls to list the files within a directory called documents with cat right over here. So we've listed the files, and then we've used cat on this file to list out what's in it. We've applied some knowledge from an earlier task to do the following. We've used ls to let us know what files are in the documents folder of this machine. In this case, it's called todo.txt. And then we have then used cat and then todo.txt to concatenate/output the contents of this todo.txt file. Where the contents are, here's something important for me to do later. Pro tip, you can use cat to output the contents of a file, so you don't actually have to navigate to that file. You can use what's called the absolute path. Don't worry too much about this right now, but this is the full path from the root of the file system, which we'll cover later, to the actual file itself. Sometimes things like usernames, passwords, yes, really, this does happen a lot. You'd be surprised what you can find. It's the equivalent of finding sticky notes on people's desks, and it happens a lot. Flags or configuration settings are stored within files where cat can be used to retrieve these. Cat will be your best friend, and trust me, you will be familiar with that command in no time flat. Finding out the full path to our current working directory with pwd. You'll notice as you progress through your navigating your Linux machine that the name of the directory you're currently working in will be listed in your terminal. So in this case, it's not listed right now, but if I were to cd into folder 1, we can see that it's listed right here at the start. So we are in the folder 1. However, if I go back to my home directory, which is just, think of your directory that the desktop, the pictures, and all that are in Windows, that is your home directory. And you can see that we just have our normal group of files here for this specific example machine. But we can see that it's displayed here on the front of the terminal. However, it's easy to lose track of where we are in the file system exactly, which is why I want to introduce pwd. This stands for Print Working Directory. I often remember this by Present Working Directory, however, print is the correct one. Whichever one works for you to remember it, this is something that you'll pick up on very quickly with practice. Using the example machine from before, we are currently in the Documents folder. But where exactly is this on the Linux machine's file system? We can find this out using the pw command like within the screenshot below. And we can see that we've done that down here. Let's go ahead and use pwd, and we can see where we are on our example machine over on the right. And we can see that we're in TryHackMe, that user's home directory. Let's break this down. We already know we're in the Documents thanks to our terminal, but at this point in time, we have no idea where Documents is stored at so that we can easily get back to it in the future. So we can see we're in the Documents folder up here. I've used the pwd command to find the full file path of this Documents folder, which we did right here, and we're returned the full path. We're helpfully told by Linux that this Documents folder is stored at Home Ubuntu Documents on the machine. Great to know. Now in the future, if we find ourselves in a different location, we can use cd Home Documents Ubuntu Documents to change our working directory to this Documents directory. Let's dive into the questions. On the Linux machine you deploy, how many folders are there? And we can see that there are 4 folders. There we go. Which directory contains the file? So we've gone ahead and already looked in folder 1 and folder 2. Let's take a look in folder 3. And of course there's nothing. Of course it's the last one. Let's do ls folder 4. And we have note.txt. So that's going to be folder 4. Wouldn't it be funny if there were no files in any of the folders? That'd be great. What are the contents of this file? Let's go ahead and cat folder 4 note.txt. And it looks like it has hello world. There we go. Use cd to navigate to this file and find out the current working directory. What is the path? Let's go ahead and cd folder 4 and then use pwd to find our current working path. And we can see that it is home TryHackMe folder 4. There we go. Let's move into task 6, searching for files. Although it doesn't seem like it so far, one of the most redeeming features of Linux is truly how efficient you can be with it. With that said, you can only be as efficient as you are familiar with it, of course. As you interact with operating systems such as Ubuntu over time, essential commands like those we've already covered will start to become muscle memory. One fantastic way to show just how efficient you can be with systems like this is using a set of commands to quickly search for files across the entire system that our user has access to. No need to consistently use cd and ls to find out where things are. Instead, we can use commands such as find to automate things like this for us. This is where Linux starts to become a bit more intimidating to approach, but we'll break this down and ease you into it. That being said, one quick meta note, find here works a lot better than Windows search. This is actually worth learning, and there's an entire dedicated room to this, and you can see a note down here for that. I do highly recommend doing this room, especially after you've completed the Learn Linux series. It is one of the most insightful rooms on TryHackMe, especially for learning a critical command, so I highly recommend it. Using find. The find command is fantastic in the sense that it can be used both very simply or rather complex, depending on what exactly you want to do with it. In fact, so much so, we have an entire dedicated room, as I mentioned before. However, let's stick to the fundamentals first. Take the screenshot below. We can see a list of directories available to us, and we can see that over here. We have our directories listed out here as well. Now, of course, directories can contain even more directories within themselves, so you can have recursion there, and you can very quickly lose things, especially if you have a lot of layers of files. It becomes a headache when we're having to look through every single one just to try and look for specific files. We can use find to do just this for us. Let's start simple and assume we already know the name of the file we're looking for, but we can't remember where it is exactly. In this case, we're looking for passwords.txt. If we remember the file name, we can use simply find -name, so this is saying that this is the search criteria that we're using, and then passwords.txt. With the command, we'll look through every folder in our current directory for that specific file like so. And you can see it has done exactly that. Find has managed to find the file, and it turns out it's located in folder 1 with the file being passwords.txt. Sweet. But let's say we don't know the name of the file or want to search for every file that has an extension such as .txt. Find lets us do that too. We can simply use what's known as a wildcard or an asterisk right here to search for anything that has .txt at the end. In our case, we want to find every .txt file that's in our current directory. We will construct a command such as find -name star.txt, where everything before this dot is considered to be up for grabs, so it's a wildcard. Doesn't matter what's there as long as it has the .txt extension. Where find has been able to find every .txt file and has given us a location of each one, and we can see that down below. And we can see a breakdown of that too. That wasn't so tough, huh? Using grep, let's take a look at grep. This is one of the most important tools as well that you'll want to learn with moving forward in Linux. This is a tool that, especially as you're learning to do CTFs and other challenges, grep is going to become your best friend. Another great utility that is a great one to learn about is the use of grep. The grep command allows us to search the contents of files for specific values that we are looking for. Take, for example, the access log of a web server. In this case, the access.log of a web server has 244 entries. That's a lot of lines. That is a lot to look through, especially if we want to do this in a timely manner. Using a command like cat isn't going to cut it too well here. Let's say, for example, if we wanted to search this log file to see things that a certain user/IP address visited. Looking through 244 entries isn't all that efficient considering we want to find a specific value. We can use grep to search the entire contents of this file for any entries of the value that we are searching for. Going with the example of the web server's access log, we want to see everything that the IP address, and I'll let you read that one yourself, has visited. Note that this is fictional. However, this access log, this is actually indicative of a real log. So great example, and this is actually something that if you are doing forensics or anything like that, or maybe a challenge to look through log files, you'll probably come across this at some point. Grep has searched through this file and has shown us any entries of what we've provided and that is contained within this log file for the IP. Use grep on access.log, and I need to go up a directory for that, to find the flag that has a prefix of THM. What is the flag? Let's use grep, and then we want to look for THM star, and then we want to look in access.log. And there we go. We can see that it's highlighted that for us as well. So we have our flag, THM, access. Perfect. And I still haven't found what I'm looking for. Wonderful song reference. Let's move into task 7, an introduction to shell operators. All right. Linux operators are a fantastic way to power up your knowledge of working with Linux. There are a few important operators that are worth noting. We'll cover the basics and break them down accordingly to bite-sized chunks. I'm going to go ahead and skip past the overview. I definitely recommend having this in your notes. However, let's talk about these operators more in detail. Operator ampersand, or the single ampersand. This operator allows us to execute commands in the background. For this case, it's generally referred to as the background operator. For example, let's say we want to copy a large file. This will obviously take quite a long time and will leave us unable to do anything else until the file successfully copies. The ampersand shell operator allows us to execute a command and have it run in the background, such as this file copy, allowing us to do other things. This is very common, especially if you're doing something that might take a while. Backgrounding it and just letting it run while you still have the use of your terminal can be incredibly helpful. The double ampersand operator. This shell operator is a bit misleading in the sense of how familiar it is to the partner single ampersand of the background operator. Unlike the background operator, we can use the AND operator to make a list of commands to run. For example, we can do command 1 and then command 2. This is very similar to Boolean logic, when you start getting into actual programming logic. However, it's worth noting that command 2 will only run if command 1 was successful. Very helpful if you have long commands you want to string up in a row. If command 1 fails, you don't want to run command 2, or maybe it'll break something. Very, very helpful. Operator, this is the single greater than sign. This operator is what's known as an output redirector. What this essentially means is that we're going to take output from a command we run, so output that would go to standard out, such as when we did echo hello. This would be the output right here. And take that and send that output to somewhere else. We're going to take it and move it to a different channel of that actual output. Don't worry too much about output channels. However, that's something that, especially as you get more experience within InfoSec, it's something you'll definitely want to learn a little bit more about. A great example of this is redirecting the output of the echo command, as I just demonstrated, and that we learned in task 4. Of course, running something such as echo howdy will return howdy back to our terminal. That isn't really all that useful though. What we can do instead is redirect howdy to something such as a new file. Let's say we wanted to create a file named welcome with the message hey. We can run echo hey and then have the output redirector operator and then the file that we want to create. If this doesn't exist, the redirection operator will create this file. However, if it does exist, it will overwrite the contents, and you can see a note on that down below here, where we want the file created with the contents hey, like so, and we can see a demonstration of that. So we've echoed hey into welcome, we've checked that the file has been created with ls, we've catted the file, and we found that hey is in that file now, and there we go. Let's take a look at the double greater than operator, otherwise known as the appending operator. This operator is also an output redirector, like in the previous operator, the single output redirector, or the single greater than that we previously discussed. However, what makes this operator different is that rather than overwriting the contents within a file, for example, it instead just puts the output at the end, which is great if we don't want to keep overwriting ourselves and maybe we want to log our information. Following on with our previous example, where we have the file welcome that has the contents of hey, if we were to use echo to add hello to the file using the single greater than or the output redirector operator, the file will now only have hello and not hey. It would overwrite it in that case. The appending operator allows us to append the output to the bottom of the file rather than replacing the contents like so. So we've gone ahead and echoed that using the append operator to welcome, then we've catted the file, and we can see that it's just added it to the bottom. If we wanted to run a command in the background, what operator will we use? That'll be the background operator, that is the single ampersand. If we wanted to replace the contents of a file named passwords with the word password123, what would my command be? That would be echo password123, and then a single greater than, and then passwords. And there we go. Now if I wanted to add TryHackMe to this file passwords, but also keep the passwords123, what would my command be? That would be echo TryHackMe, and then double greater than for the append operator, and then passwords. And there we go. Now use a deployed Linux machine to put these into practice, and I definitely recommend playing around with this just so that you're used to it. That being said, let's move into task 8, conclusions and summaries. Nice work on getting to this stage. We've covered quite a bit for your first interactions with Linux. However, these are the most essential functions you're going to be using whenever you interact with a Linux machine. I hope this room hasn't been too daunting for you to power through with these things very quickly, as we're introducing a lot very quickly. However, practice is key in this specific case. To quickly recap, we covered the following: understanding why Linux is so commonplace today, interacting with your first ever Linux machine. We ran some of the most fundamental commands, we had an introduction to navigating around the file system and how we can use commands like find and grep to make finding data even more efficient. And then finally, we learned how to power up our commands by learning about some of the important shell operators. Take some time to play around in this room. When you feel a bit more comfortable, progress on to Linux Fundamentals Part 2. Go ahead and take a play around, and then you can click on this link once you've gone ahead and terminated this machine to move on to Part 2. That being said, let's take a quick look at Task 9, and I'm going to show you how to terminate your machine. So this is a link to the second room in this series. I definitely recommend moving on to it once you are comfortable with these commands that we've introduced. Maybe run them a couple times just to start getting a little bit of practice with them, and then you'll want to terminate this machine. If you scroll up, you'll find this red terminate button, and we can press it right here, and we've closed that machine. If you ever have issues with launching a machine, and you might have one still up from a previous room, you probably just forgot to terminate, so keep that in mind. Let's go ahead and mark that as completed as we've terminated the machine, and then we can go ahead and mark this next one as completed and join the Linux Fundamentals Part 2 room by clicking that link. That's going to do it for this video. I will see you next time in Linux Fundamentals Part 2, but until then, happy hacking!